Hi, my name is Eddie. I am a postdoc at UC Berkeley, advised by Sanchit, and I'll discuss about the following. First one is about how to collect synthetic sensor data using Scenic, and then the second part is using VerifAI to test different components of your interest, such as perception, behavior prediction, and plannings, using VerifAI and Scenic. So first of all, regarding sensor data collection, using Scenic, we can, and depending on what the simulator allows you to collect, for example, in Carla, it allows you to collect detailed labels like semantic segmentation, which can otherwise be quite expensive to collect if you were to do it manually. Also, LiDAR segmentations are available, 2D, 3D bounding boxes over each objects of interest, as well as some depth images. Right? These are benefits of using simulators. And now that we have Scenic, which allows you to fully control the contents of the scenario as you want, now you have the capability to collect these sensor data. And so how? So what I'm about to show you is a feature that is currently being implemented, and hopefully you will have access to it soon. But it looks like the following way. So suppose in Scenic, so what I'm showing you right now is a snippet of a Scenic program. And here, let's say we have a simple case where we have a lane, and we're going to place a spot which is on a center lane, a center of a lane. And we're going to specify the model to be Tesla Model 3, and here's an ego, which is placed at that spot, right? So here, what you need to focus on is this part, called with sensors. And here, we're defining what sensors we want to collect and what name we want to give. So here, we say, okay, we want to collect front RGB sensor data. And here, offsets are basically defining the offsets with respect to the center of the vehicle that you want to place the RGB sensor data on. So, and also the second part is semantic segmentation label that you want to also collect. And in this case, the offsets are the same because you want the semantic segmentation for the RGB data that you're collecting. And now I want to draw your attention to the pink box below. And here you see record. So now that you define what the sensors are, now you want to specifically specify here that record the ego's observations. So all these data that you're defining, the sensor that you're defining, you've given this name, front RGB and front SS. And you can access those, and those are automatically saved into ego's property called observations, which you can access by saying ego.observations. And this is a dictionary, so you can access that specific sensor data that you want using the name that you gave, which in this case is front RGB. Yes. So the question is, can we add multiple sensors? And yes, you can. So you can add a RGB sensor. I mean, here you already have two sensors, which so it's more than one. But if you want to add LiDAR, yeah, with I guess different offsets, right? If you want to place in different, yeah. So yes, you can add multiple sensor data, sensors you want. Mm-hmm. Yeah. So to continue, so you access the ego observations and using the name that you specified above, and then you're saying record these as front RGB. And now this time, the one you're specifying for the second time, front RGB, that is what you're defining the name to be as you're saving the data into simulation results. So recall, when you run the simulation, after each simulation is done, you get the simulation result object, which contains the data that are collected from that simulation. And so basically, we're just naming here by saying as front RGB. Then if you go into simulation results, you can search for this property called front RGB to access the data that you collect. And in this case, look here, you can specify every 0.1 seconds. So you're defining the polling rate of the sensor data, which is in this case 10 hertz. Yes. Someone has a question. Oh, hi, Asma. Go ahead.
Yeah, I have two questions regarding the sensors. The first one, can we change or modify the sensor parameter? For example, the RGB camera.
So the question is, can you modify the configuration of the camera?
Yeah, and the rest of sensors.
You mean during the simulation?
No, here for the first pink box, there is option for creating the sensor, right? Two sensors.
Huh?
Yeah, it accepts only the offset, or we can also change like the image resolution and those parameters in Carla.
Yes, you can. The question is offset the only property configuration of the sensor that you can change?
Yeah.
Can you also change other things? For example, let's say if it's RGB sensor, like such as resolution or the dimension, in other words, the width and height of the length of the data and so on. Yes, you can. Offset is just one property that we're showing as an example, but you can change other properties of your interest.
Okay, another question regarding the record. Okay, it will save data from two sensors right now. Will they be time synced?
So these two. The question is, these two sensor data that we're recording, are they going to be synchronized in terms of time? Yeah. And yes.
Okay, perfect. Thank you.
Yes. What's the what? SS. Oh, so the question is what is SS sensor? It stands for semantic segmentation. So when I say semantic segmentation, like this, like this is the actual image, and this is the label on top of it, defining where the lane is, where the car is, and so on. Yeah. Which is expensive to collect if you were to get it from a manual, like human labeling all this. Why? Well, imagine you're the human labeling this manually, coloring different regions. Yeah. So, yeah.
I saw like 0.1 second every 0.1 second. So is that bounded by the time step of the Scenic simulation, Carla simulation, or the Scenic scenario?
Yes. So the time that is defined here is with respect to the Carla time. So Scenic, for example, like by default, Scenic is communicating with the Carla simulator at 10 hertz speed, right? So based on that, then that is the same clock that we're using for collecting this. Yeah.
So if I couldn't go like deeper though, right? I couldn't make it a smaller time frame.
Oh, you can. However, if you want to, then I think you will have to you may need to increase that communication between the Scenic and the simulator, which is definitely possible. Yeah.
So this, just to add to that, this rate can't be faster than Scenic.
Exactly. Yeah.
Because this is going to get rounded to Scenic time steps.
Yeah.
So this allows you to capture data less frequently than every time step. If you don't put the every 0.1 seconds, right, then you get an observation every single time step. And the problem with that is that for some very large data, like LiDAR point cloud or something, maybe you don't want to save that every single time step, especially if you have a small time step. This allows you to then save it less frequently. But if you want to save it more frequently, you have to decrease Scenic's time step, because Scenic is only checking in with the simulator at that rate anyway. So it can't gather data faster than that.
Yeah. Any other questions? Cool. All right. So that's the end of the synthetic data, sensor data generation. Yeah. No, it's fine.
So I assume all the sensors, when you collect the data, they're synchronized at the same time. But there are times where if they were out of sync, it's actually more realistic. There are those two things out.
Repeat the question.
So the question is, in terms of these two sensors being collected at the same time, what if we don't want it to be collected at the same time?
Yeah, almost like, your sample, all these other things, you can do a probabilistic bias. Why wouldn't the sensor be sampled in the probability?
I mean, I think it's the sensor data as collected by the simulator, right? So the realism of the simulator, first of all, it's whatever the simulator produces, right? And so if in the simulator you wanted to capture this mismatch, right? And if that exists in the simulator, it will be reflected in this data collection, right?
I'm just wondering, just say, if say I sample 1 frame per second, but all of sync, can that be final distribution?
Yeah.
Right? Is that could actually sleep?
Yeah. I mean, you might need to define a least count where you can actually capture those discrepancies. So you need some information about the sampling rates of the different sensors and then compute the time interval to sample, which is typically a fraction of the individual sampling rates.
Yeah, so we don't have anything built into Scenic. I mean, this is the prototype thing, which is not in the main branch anyway, but this will be in soon. But this doesn't include anything like that. I mean, nor does it include things like models of noisy sensors, right? Yeah. This is data, as Sanjay said, coming straight from the simulator. So it's probably close to ground truth, right? Unless the simulator has facilities for adding noise.
Exactly. Yeah.
And some simulators, you could write extra code on top of this, right? Like if you want to simulate drift or something, or different rates, right? You could basically have Scenic collect the ground truth at a very fast rate and then subsample that to get the actual data that you're going to use for training.
It could be done.
You could. That's right. Yeah.
In your case, you're asking that question because you want sensor data collection that reflects how the system actually works.
Well, because sometimes in the real system, they're often out of sync, or
right.
When they do go out of sync, there's certain failures.
Yeah.
So, even just the ability to show, if I perform synchronization events, that they, half a second or something, that can improve the failure rate. They can reduce the failure rate, things like that.
Yeah, I mean, real sensors have noise, they have inertial delays and things like that. So, first of all, the simulator has to be able to capture that, and then we have to expose it to within Scenic. And secondly, I think you need to know about these differences in sampling rates. Right?
I also think like that. I mean, maybe even post-processing, we can kind of deal with it if we just check out the simulation. I'm not sure.
I guess as Daniel was saying, in the worst case, you set the Scenic time step to be something very fine grained, and you capture everything and then you post-process. Yes.
I'm asking this so I can better understand the use case, but isn't that like two different issues? What, like right now, what I'm presenting is if I want to just collect the data, right? And I think what you're mentioning is if I set the frequency of the sensor functioning, like each sensor at a certain point, would that cause a failure in the overall system?
Supposedly we want to write a scenario, right? Some kind of a sensor fusion simulation.
Yeah.
To write that scenario. Or we want to pass the exact failures. So when the sensor gets out another thing, it could actually fail. So sometimes you can post-process things, but then there are times when you actually just want to run your simulation. Then they do go out of the sync, it actually causes failures, right? In the simulation. You want to take that into account of your simulation.
I'm just trying to differentiate the sensor collection part and it seems like there's another part. But are you suggesting that perhaps this collection part itself is causing delay and may affect the synchronization, or?
I'm just asking if there are ways to even collect data during your simulation that actually you can have like out of the sync and you can relay out of sync sensor. Because that's actually kind of realistic in the sense of and you can have like odometry runs like very, very fast, where the camera really runs like maybe at most.
And then you wanna, let's say you collected that data, you wanna replay that back and then reproduce the failure. Is that what you want to use it for?
Maybe I misunderstood your sensor. So is your sensor says primarily for data generation, or your sensor also could be used to, for example, to policy? It can be used.
Yeah.
I think this is a good point, and let's.
Okay. Yeah. Okay. Now moving on to the next part about VerifAI. So let me start with a question. I think Daniel briefly mentioned about what VerifAI does, but why do you see why we had to create VerifAI? Can somebody maybe briefly explain why we had to create VerifAI? We're certainly not creating tools for the sake of creating tools.
I mean, Scenic is randomly sampling for a huge space, but the seeing the sample may not actually be the edge case we're looking for if we're talking about verifying systems. So VerifAI, I'm guessing, helps you find specific things that satisfy your conditions, as we talked about.
Absolutely.
So we're searching for a scenario.
Yes, so that searching aspect is important. Maybe another one? Yes, searching smartly.
Certain scenarios that would not like meet things that we want, or like are.
Yeah, searching scenarios that like the failure scenarios, right?
Yeah.
So then, how do we define failures? Do we have a capacity, like a functionality in Scenic to define the failure? Right. Scenic was only about environment modeling, right? So that's another aspect, right? We need to specify what the evaluation metric is, but Scenic doesn't allow that. So those are I would say, two important aspects why we had to create another tool support around Scenic, because Scenic is only about modeling the environments, right? So as you mentioned, though, one motivating issue is that we are sampling from a distribution of scenarios, which can be huge, and so how do we explore this? And there are there's a trade-off to consider here, right? One is we want to explore as much of that space as possible, but at the same time, we want to find as many counterexamples as possible. So if you just look at the counterexample, what may happen is once you identify a failure case, then we can exploit that by sampling very nearby scenarios around that to find a lot of counter examples. However, that may not be what we want. We also want to be able to explore the whole space of distribution at the same time. So there's a trade-off. So how do we balance this trade-off, right? Those kind of things all rise in the search problem. So in VerifAI, it takes these three inputs. One is either system or its component, like perception, behavior prediction, and so on. And then environment model, which is in the form of Scenic program, and the evaluation, and the evaluation criteria, which you saw how it was being, how you can input to verify, right? And then now, given these three inputs, what happens is that the distribution, the search space, is extracted into a semantic feature space in VerifAI, and from there we start to sample, and using the search engine. And this search engine is basically a sampler. That is sampling from this distribution space, right? And what happens is you sample one, you send it over to the simulator to generate, and then for the monitor, looks at the evaluation criteria that you gave. And so after simulation is done, the monitor looks at the it traces the trajectories of all the objects in the scenario, and then try to evaluate, and then output a score based on the evaluation criteria that you gave. And that information is relayed back to the search sampler. So what happens is that so as this history of the environment that was sampled and the performance result starts to get logged, now you can just start doing some more intelligent sampling, right? Based on the history of what you sampled so far, right? So that's the idea. And so in VerifAI, there are different search strategies or samplers that are supported, and you can add your own samplers too, if you have them. But things that are supported already right now are things like Bayesian optimization, multi-arm bandit, cross entropy, blah, 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 right? And as to the use cases of VerifAI, there can be many different use cases, things like fuzz testing, falsification. Falsification meaning you intentionally search for scenarios that violate your evaluation criteria more and more, right? So that's what I mean by falsification. And you can also, and once you collect and identify multiple counterexamples, you can start doing failure analysis as to, okay, which environment parameters that we sampled tends to highly correlate with the failures that we see, right? And data augmentation and other use cases. Any question?
What's the length?
For what? Here?
Yeah, like what is the format of that?
What is the format of the specification?
Yeah.
We'll go over that soon. Yeah. But basically, we have a generic template that you can fill out to input your evaluation criteria. You can just you have two options. One, you can just plug in a Python function that models your evaluation criteria, or the other one, we also provide metric temporal logic as a means for you to specify your specification if you want.
And the Python function could either be a property, Boolean, or it could compute a real value number as well. So we support both Boolean and quantitative specification.
Yes, I was thinking that Scenic is a pretty high level kind of write something like this so that eventually kind of that my will generate data. Can I say this kind of project?
So as Daniel covered, Scenic has the ability to write. You can write temporal logic properties in the Scenic mode itself. And then, of course, in VerifAI, you can also write requirements. But then I think they play slightly different roles.
Yeah, you can write, like what you were just describing, eventually something, whatever, can be expressed in metric temporal logic, like Eddie mentioned. So you can basically, if you're using a Scenic program, for example, you can record various signals of interest from the Scenic program. And then on the VerifAI side, say something like, within 1 to 5 seconds, this signal must be greater than the something. Right?
Kind of thing.
So it's much less sophisticated. It's just metric temporal logic. So you just have those temporal operators, and you just have real valued signals which you get out of Scenic or from something else from the simulation. So there aren't a lot of conveniences in terms of being able to write operators and things in there, but you can write a custom Python function as Sanjay mentioned. So as long as you can compute it in Python, you can do it. There are some things we're working on to improve that. So actually, Eric has a prototype extension of Scenic where you can now write the specification in the Scenic program also. So not just the specification of the environment, but also the system level spec, and have that be turned into a cost function, etc.
Okay. Yeah.
Is there any variable that these optimizers do not search for yet? Like, does it even check for the spawn locations of the objects, for example, while searching for a better scenario?
Oh, so the question is there any variables that the sampler, the search engine, the sampler is not tracking when sampling? Is that the question?
Yes.
Yes, it depends on how you write your Scenic program. Let's say, so for example, you can specify what variables you want to sample by specifically putting like param in front of it, or like verify range, right? Kind of things. However, if you don't specify that and create a Boolean, a flag, like in the like behavior function, which gets turned on and off, and you didn't specify that with param in advance, then it wouldn't be tracked. Am I correct, Daniel?
Yeah, and so if you don't tell, if you just have a distribution and you don't say it's an external parameter, then it's not going to be exposed to the search string. What I think Eddie was alluding to is there's a limitation of the current setup in VerifAI, whereby you can't use verify range and those other external parameters inside behaviors. Right, so they can only be parameters sampled at the start of the simulation, not all the way through. That's because some of VerifAI samplers expect the feature space to be known ahead of time that you're searching for. I think we might have talked about this actually last night. We have some ideas for extending that, but there's a current limitation. But I mean, to your original question, there are also maybe many aspects of the simulation which are not even available to Scenic, right? So I gave the example last night of the clouds in Carlo, right? We can't search over those because there's not even an API to control those, right? So there may be many aspects that are not exposed, right? But anything that the simulator interface makes available to Scenic, you can also have verify searching. Okay.
Yeah, and probably we think this is probably a more intuitive way of approaching this problem, because we don't want to by default take all the variables, right? Because that may not be what the user wants. So we just want to allow users to specify, okay, what variable you want to track, and then those will be looked up. Those will be referenced in the sampler. Piggybacking on Daniel's explanation, another variable which may not be possible to track are, for example, shadowing effect in the simulation, which is indirectly controlled by the time of day, which controls the location of the sun. And based on your location, you may see different shadowing effect, which is like more of a visual effect that is rendered as a result of other environment parameters that you sample. But those things may not be like, oh, is there a shadow? Am I in the shadow right now? Those kind of things may not be able to be tracked. Yeah. Okay. So now, in the interest of time, I'll move on. Please save your questions at the end. I'll be wrapping up very soon. So now I mentioned about the whole purpose of using VerifAI in the context of testing perception, behavior prediction, or planners. So how would you do that? This is, again, going back to the Scenic program. Going back to Scenic program here at the top, you can import. Let me move this to this. In fact, and hide the floating. So in fact, you can import, for example, let's say if you're using PyTorch or TensorFlow, import that, and then actually import your model. And then at the below, you can record actually into the simulation results, the evaluation results, and the performance outcome by inputting these two sensor data that you want, right? So here you have the, sorry, my mistake. Right now we're recording the output of the model, not the evaluation. So to the model, which you instantiate at the top ML model, now you're inputting the front RGB sensor data you sample, you collect, and then you also input the semantic segmentation into it, and then you're getting the output of it as a result, right? And you're saving that to ML performance in the simulation result, right? So now then going to the VerifAI side, going back to the question that was asked before, how do we specify the evaluation criteria in VerifAI? So again, as I mentioned, at the top, line 1 through 9, there's basically, it's just like a template that you just fill out. In this case, we're defining using a Python function. So here, by default, in this function called specification, you are already given, assume that you're given the simulation result object after each simulation is done. And here you're referencing the output of the ML model using this name, ML performance. Why? Because that's what you named it over here, ML performance at the below, right? So because you said, okay, so that's what you do. And so once you get that output result from the model, which is a time series data right now. Now, if you want to, for example, compute the mean IOU in this case, then you can get that and then output that result, quantitative result per simulation. Is that clear? And then there are other parameters that you can also define in VerifAI, things like, oh, how many simulations you want to run, and how long would the how long each scenario should be. In this case, we set it to 20 seconds. What is a failure threshold in case you want to convert this quantitative result into booleans? So this, if it's above 0.5, then it's success, lower, failure, those kind of things. And also these parameters, like, do you want to save all the environment parameters that are sampled that result in failure into an error table? If you say true, then you'll get a CSV file at the end with all those information. And likewise for the save table, and so on. So a quick demo. So running Scenic with VerifAI now, like going back to that question, the scenario that Daniel covered early on with badly parked car case, suddenly driving onto your lane. And let's say we ran this for, I don't know how many times I set this for, but I think I set it for maybe 3 or 5 times. But let's say we went through all that. After it runs, so I set it to 3. And in this case, all 3 of the cases were correct. It didn't result in failure. And in this case, the failure was not using the sensor data, but it was using the distance between. But the point that I'm trying to make is that after the VerifAI runs for the number of times that you specified in simulations, it will output, for example, this type of CSV file with save table, in this case, save table. And if you open up that CSV file, so I'm importing it to Excel sheet, you'll find, okay, what are the variables that were sampled? So starting from like the object position, RGB color, and also car model, and so on. So, and at the very end, you're also given the performance per sampled environment, right? And so what's the implication of this? So previously, Sanjit covered this video, right? And here we were using VerifAI, where you input these 3 metrics, scenario, and the system of your interest that you want to test in. And we were using VerifAI to search for scenarios that can actually that result in failure, and we wanted to see if that also results. We can reproduce that at the track testing site. And what were we doing? Well, we were visualizing all this plot. Do you remember all this, right? Well, where did we get this from? From that CSV file that I showed you. And so, for example, in this case, we're only plotting with respect to 2 dimensions from that. So 2 columns from that CSV file. And then the color of these are the row, which is the performance results, right? So this is basically, we ran this for, I don't know, I think 2,000 simulations. And you can do this. You can start visualizing, analyzing, and trying to identify different, for different use cases. Yeah? Is that clear? Okay. So, yeah, that's it.